Hello and welcome, everybody. Thank you for joining us today for our webinar, Become a Technology Apostle, How to Successfully Discover, Nurture, and Implement Emerging Technology. I am Wilson Miles. I'm an Associate Research Fellow here at NDIA's Emerging Technologies Institute. Today, we're going to be discussing how to think about the emerging technology lifecycle and the types of considerations or constraints technological change agents must anticipate as they look to ensure new technologies are adopted. So leading us through this discussion is Dr. Mike Simon. He's the VP of Advanced Technology at Parallax Advanced Research, which is an advanced research institute based in Ohio. So some administrative items before we get started. All attendee lines are muted. If you have any questions during the webinar, you can submit them via the Q&A button on your screen. Questions may be submitted at any point during the webinar, and we'll do our best to get through all the questions during the Q&A portion of the session. We're recording today's webinar for members who are unable to attend, and then we're going to post this recording to our YouTube channel and our social media in the next couple of weeks or so. And so with that, I want to thank Parallax for sponsoring today's webinar. And then, Mike, I'm going to hand it over to you and start whenever you're ready. Thanks.
Thanks, Wilson. Hi, everyone. Thanks for joining this webinar. My name is Mike Simon. I'm the VP of Advanced Technology at Parallax Advanced Research. Parallax is wholly affiliated with the Ohio Aerospace Institute. The topic today is becoming a technology apostle. What that means in terms that you'll want to understand is really how to become a technology apostle personally and champion technologies and insert them into applications. I'm going to start with an overview. So the first question people always talk about is, what is emerging technology? It's not just technology for technology's sake. I can't come up with a better widget. We were just talking before this about a squirrel invading someone's backyard, and how do you deter the squirrel from actually getting into the bird feeder? You need an application, right? So it can't just be technology randomly. It's got to be a technology for an application. So like in that context, we need technologies that'll help us deter the squirrel. And once we find those things, we have to basically plant them in terms of an analogy to growing like a plant. And we have to put them in soil, we have to water them, care for them, prune them. And eventually we'll get some technology that pops out like a flower that is what we need to be successful in a marketplace with an application. Now, you've probably heard a lot about disruptive technologies over the years. There's actually a very specific definition for that. Disruptive technologies are initially less capable and lower cost than existing technologies in the marketplace that are dominant. And what happens is when those are introduced, they eventually displace those more capable and expensive solutions from the market. Whereas I want to highlight the concept of paradigm shifting technologies. These are technologies that don't need to be cheaper or less capable, but they really need to have delivered more utility and often many orders of magnitude more utility than existing technology in the marketplace. So paradigm shifting technologies, again, are really distinct from disruptive, and they change how things are done. They change the standards of practice, they change entire industries over longer periods of time. Now, emerging technology is not disruptive or paradigm shifting in and of itself. And that sort of gets back to where I started, where you've got technology for technology's sake is necessarily neither. But what really matters here is how you apply the technology. So when you have the right application meeting the right emerging technology, you almost always having a paradigm shifting technology, and it's usually disruptive. So typically for market entry, you want things to be lower price point versus the state of the art and more capable, just because of business dynamics. So let's sort of work through the life cycle here on emerging technologies. So the first thing that happens is in an application space, there has to be a void, and usually it's a gaping void in terms of capability. Most people may not actually be able to see this void. So most people, if in the context, it's latent to them. it takes a special person to sort of say, I need a widget that does the following in this technology. And once they know what the void is, then they can basically go through and think about, okay, what technologies exist currently in the world, and what's basically um, maybe nascent, so it's brand new, what's been overlooked in the past, so it may have been looked at years ago, but there are various reasons it wasn't adopted, and maybe what's been misapplied. So it could have been applied to one application versus another, and just really not taken root there. But in this current void, in this application, it may be the perfect technology. And I've had this happen to me in my career. Uh, so, again, you've got the void, you've got a person, and this person we're going to call the change agent that senses the void, and then they go ahead and look at what technologies are out there through surveys. Uh, and this is done usually independently. It's not like a big group thing. And then they kind of just say, okay, here's the technologies I need to create or be a champion for. So by discovering this mapping between the void and the technologies, they really effectively construct the technology in a framework to be emergent. So once they have that piece, they have to actually nurture this technology. So if it's technology that's being completely created from scratch, that's again back to the plant analogy. They've got to plant it in the ground, they've got to water it, they've got to prune it, train the vines up, and so forth. This process can take a lot of time, even decades. But typically, this is done sort of on the back burner. So it's again not apparent to most people, and there's business reasons for that as well as just professional reasons for that. These things are risky to do, so you have to make sure that you do things sort of in lockstep with stakeholders. So you get the stakeholders sensitized to this technology and its capability before you actually bring it out to the market. And then finally, when the nurturer, this change agent, believes it's ready to go to market, then they then put it into the market and go full bore. Don't really go in sort of a halfway stage, because you have to make sure this technology is going to succeed as the change agent. And then really what happens is market dynamics take hold, and it's either going to prove its emergence in the market space, or it's going to fail. And we don't hear about the failures too often. We only hear about the successes, but there are lots of failures. If you look over history where people tried to introduce technology for certain things where there might have been an application mismatch and it was a business flop. And there's other causes for that as well. So be thinking about this cycle here where you've got the void, the technology, the change agent, discovery, nurturing, and then market implementation. I'm going to go through three use cases that really illustrate this life cycle. The first is going to talk about the computer graphics resolution revolution, uh, basically taking over traditional cell animation and visual effects. And that's happened over the last really 45 years or so. And that's a completed life cycle. And I'll get to that in a second. The second use case is really mid-life cycle. And I'm going to discuss blockchain technology incorporation into the uh, wine market, specifically to combat wine fraud. And I'll discuss that second. And then third, I'll talk about a very early life cycle concept. And it's really, let's say we want to reconfigure production lines in the US to build almost anything within 24 hours. How would we actually approach that from that life cycle perspective of being the change agent, finding the void, uh, looking for the technologies, and moving through that process? So I'm going to start again with the computer graphics revolution life cycle. I'm going to spend a little time on this chart because it's complicated, but it is very illustrative. So on the bottom axis, you have years starting 1975 through 2025. On the top, you see different stages of this life cycle. You have void and nurture to the left, implementation and paradigm shift in the middle, and then this new paradigm where the paradigm is shifted and now it's been embraced by the mainstream in that particular application on the right. There's two curves there. The blue curve has to do with the number of films using digital effects. It's estimated um, over that time period. and then you'll see a yellow curve, and that has to do with uh, basically generative AI. I'm using as a proxy peer-reviewed publications because there's not a lot of data on actual peer-reviewed uh, or generative AI in Hollywood, but I'll get to that in a little while. So if we look to the left, you'll see in 1975, there was a particular change agent, and I have to stop for a second. I'm going to focus here on the what, not the who. You can go and make your own inferences and do your own research to figure out the who if you're interested, but I want to focus on the what because that's perhaps what's more interesting here. So there was a change agent in 1975 that started a special effects studio, and that sort of kicked this whole cycle off. A year later, though, there were other people actually thinking about this transition from analog effects to digital. And there was a movie that came out where they had the first animated human hand and head sequences. And that was about 51 seconds of computer generated imagery. And you'll note there, I have some significant events in green, and then the stars talk about foundings of different effect studios. And then the yellow circle is the closing of certain effect studios. Uh, so then if you move from 1976 to 1977, that FX studio participated in a very large production that was very successful, and that had about 45 seconds of vector graphics included in it. So you can see right off the bat, the initial couple films were having on the order of a minute of computer generated imagery. But it sort of took a while for this to kind of ramp up. So if you look sort of over the timeline, you've got the founding of a number of visual effects studios. Notably in 1979, that first effects studio started their own computer graphics division. And then as you progress in time, 1981, the first realistic human shading in another film, and that was still maybe a little over a minute, but the graphics got definitely perceptibly better than from the 1976 film. And then in 1982, you really had kind of the first landmark where you had about 15 to 20 minutes of CGI. So there was an order of magnitude jump basically between 81 and 82. And then things started getting interesting. You had a number of more studios being founded. In 84, you had a film with 27 minutes of CGI. Um, then you had in 85 the first photorealistic CGI character. Now, notably in 86, that computer graphics division from that first FX studio was sold to a second change agent. And that second change agent started an animation studio. So in this case, you can actually trace the progression of digital effects uh, in animation production all the way back to two people, which is really kind of interesting from my perspective, because it says two people can have a huge impact on an eventual market paradigm shift. Anyway, I'm not going to go through all these, but if you go up from the 80s, there's the first morphing, the first water. Um, but in 93, there was basically the thing that inflected the curve, and it was the first photorealistic CGI creatures. Now that's important because that's when everyone in this industry said, we've got it. We can actually now integrate this into films. And the data backs that up because you can see that the adoption rate of digital effects starts to increase exponentially, and it starts to level off a little bit in like 2010. And that's consistent with our experience in kind of the modern world. But you've got a number of firsts, from 95 all the way through 2009 that are kind of interesting. Um, but it's really just refining sort of the same processes that they'd been using originally. And part of it had to do with they didn't have enough compute power to really make this work in some cases. But I will point out in 2003, they started to deal with motion capture being markerless. Back in 1999, they had motion capture, but it was with markers, and markerless motion capture was important because it gave actors freedom to do things they couldn't otherwise do. And then you had performance capture driven films starting in 2004, and just kind of moving along that paradigm. You get to say around 2017 and 18, you've got the first film coming out with massive amounts of AI using to generate some imagery. And then in 2019, something called the lead volume, which is really as far advanced as you can get on this this motion capture because you basically shoot actors against a lead volume, so a lead wall, and you display imagery and capture it all in frame, which opened up even more possibilities. But you can see there the curve really starts to saturate in asymptote. So what's interesting is right now we're kind of at the next cycle for this renewing, because generative AI basically is now going to take over. And there's a few articles in the popular press lately, I even saw one this morning, talking about AI being used in various films and uh, uh, serial shows. Um, Now, notably this year, there was a film made called The Death of Film by two college students, and that was all AI generated. It was actually an extremely long-running film. They did not go for the record of the longest film, but they did it basically an hour shy of that. But this is important to note because we're right at that point now where everyone's got to get off of this digital effects bandwagon and onto the generative AI bandwagon. And I'll explain why in a little bit. It really has to do with cost and efficiency. All right, so to sort of prove my point, I decided to make a short animated film. It's sort of a 3D animation style film. It took me about 80 hours to make a 5-minute short. Um, there's lots of problems with this. So the generative AI isn't quite ready, but it's getting really close. And the way it's advancing rapidly, I think it'll be ready in maybe 6 months to a year at the most. And obviously the film studios have access to more advanced systems, but there's some really good ones that are available in general for general use. So the problems are when you're looking at things shot to shot, there's really not enough continuity in the scenes. Um, so like if you see like a car in one shot and go to the car in the next one, these tools will just generate a different car, even if you prompt it correctly. So I figured out some ways to hack around this. If you're interested, contact me later. I can explain how to do it. Um, Likewise, these tools are not good with physics awareness. So you'll have things like penetrating other objects. So like a person might go through a car, and you'll see an example of that. Um, so, for these tools to really get to the next level, those are problems that the people making these tools know they have to address, and they're actively working it. But for now, you're kind of limited in what you can do without hacking your way around these things. All right, my nieces that are 6 and 7 love this movie. When I was developing it, saw me doing it, and they said, "What are you working on?" And I showed them, and they got very excited. And every time I see them now, they want to watch this. So with that, I'm going to play Tom's Day.
Breaking news. The robot virus Strike spreads globally. It has already infected France and is now making its way to England. The Bureau of Autonomous Robot Factories advises everyone to turn off their robots, stay calm, and remain indoors until an antivirus is found. We will keep you updated on this evolving situation.
All right. Hope everyone enjoyed that. You obviously saw some of the problems. The car wasn't quite right in the one shot, and the character went through the car. No matter how many times I prompted the AI system, it just could not figure that out. And I used a whole lot of different models to try and get that to work. Yeah, thank you for all the applause. Appreciate that. Uh, so why is this even important for defense? Well, there's actually customers starting to ask for this type of thing now, not an animated short film, but DARPA has this ERIS program where they're asking for videos up to, I think it's 7 minutes in length on new concepts in a variety of application spaces. And they want videos. Likewise, there's another entity in the government that has this trade wind uh, activity going on. And they also want videos in a similar vein and duration. So from my perspective, it's actually a lot more appropriate and fun um, to make a video that's very succinct, telling the major points of what you're proposing, technical features, etc., as a small film than just a talking head with charts, which is more the traditional way to do it, obviously in a meeting context. Um, but you can do this really cost effectively, and it can be done by anyone. It doesn't have to be someone that's well versed in making videos or animation or anything like that. Um, Also for defense applicability, this is well beyond deep fake. This is all fake. In fact, some of these tools are so good, I could take some pictures of myself and a few voice recordings and make myself a digital twin, literally. And I can then generate movies with myself acting in these films. Um, that's a little bit incomprehensible in the sense that I can then basically falsify anything I want um, regarding anyone in terms of video and audio. Uh, and it's extremely convincing if you do it in high enough resolution and have the right kind of noise with the right, uh, mapping to certain camera type sensors and lens systems. It's going to be hard to tell the difference. Um, so that's really interesting from a defense perspective, but it's also scary because we have to protect against those sorts of things. But again, maybe more importantly right now for me, it's a really good example of what automation and AI can do for increasing cost savings and efficiency in defense processes. So just to give you some quantitative numbers, I won't go through the exact details, but let's just talk about cost for a second. It was 87% less cost and 99% less time for me to make this than if I had just paid someone else to do it at like a small animated short studio. Um, you can look through the details a little bit later, but in effect, this costs probably like 6.5 thousand if I had in fact used company time. I was an animator at an animator's salary. I actually did this mostly on my own time, so it didn't really cost anything other than the tools. But the tools are cheap. The main tool I use, I'll talk about in a minute. It's called LTX Studio. For 90,000 seconds of video, it's like $125 a month. I also used a little bit of ChatGPT and Sora and an audio generator called Suno. And again, they're all relatively inexpensive. So if you're trying to do this for DARPA or another part of the government is video submission, it's very cost effective. And I'm just one person. Most of these things take, hundreds of people to make in general, if they're an animated movie or short. So again, it's not as good quality as what's done out there professionally, but it's pretty close. So let me kind of walk you through LTX Studio just briefly so you have an idea of how easy this is to use. And again, this is applicable in other contexts, and I'll talk about that in a little while. So it's a web-based tool. I actually was sitting next to those nieces I mentioned earlier, and they said, Dr. Uncle Mike, we want to make our own movie. I said, okay, what do you want it to be about? And I typed in the paragraph on the upper right there. They wanted it to be about a girl named Naomi who turns into a glitter dragon that instead of fire breathes out colored rainbows, what you'd expect 6 and 7-year-old girls to want. She's got a friend named Violet who's a bird with a unicorn on its head, and the bad guys are called shadow spikes. So on the bottom, you can see what the AI tool came up with. And those are pretty good for what the characters might look like, in my perspective. On the left, you see what it does after you okay the storyline that it sort of updates. It'll generate scenes that you can then modify further and generate motion on. So I did this with my nieces, and it probably output about 7 minutes of video. Uh, there was no dialogue, but you can add dialogue. And this tool will actually give you sound effects as well as music if you want it. So it's very easy to use. And basically the way I use it is I output the scenes into a video editing software and then just edit it manually. But you can edit it just as well in the tool. And there's other tools like this. This is just the one that I found the most helpful for what I was trying to do. All right, let's transition now to the mid-life cycle. So we went through the completed life cycle for CGI, computer graphics, going from digital, manually controlled to generative AI. Now we're going to talk about something that's more mid-life cycle, which is the incorporation of blockchain into the wine market to handle combating wine fraud. Most of you probably don't know much about wine fraud. Wine, in terms of global revenues, is a very big market. It's about 350 billion industry worldwide every year. Wine fraud goes way back to Roman times, and it's been going on ever since, getting more and more advanced in terms of what people can do to try and pull off frauds. The types of frauds range from counterfeit, what's called adulteration, where you basically just mix in things to the wine that wasn't really supposed to be there, through just mislabeling. They take a very inexpensive bottle and they label it with a fake label that says it's a really expensive bottle, all the way to just embezzlement on the part of people involved in the business aspects of the industry, as well as investment scam, which is basically me saying something like, I've got some wine in France in a warehouse that's owned by some very rich people, and they want to take a loan out against that as collateral. Would you invest, for the loan to get interest? These kinds of things happen actually pretty often, and more often than you'd think. So it's a big problem because if you look at, the numbers of 5 to 10% of fine and rare wine being fraudulent, and then up to 30% of consumer wine being fraudulent, that's a big number. That's like $30 billion for consumer and, 10 to 15 or more for, um, uh, for fine and rare. And I did talk to the world's foremost expert on this. Her name's Maureen Downey. So she's the one that really understands this well. I did some web scraping a while back on this as well. Here's sort of an exhaustive list of types of wine fraud that I found in the literature. This is not peer-reviewed literature. This is basically just press releases and things of crimes and frauds that had occurred, but it's a good place to start. And what's interesting is by monetary value, you actually see investment scam being the number one impact to the consumer, followed by counterfeit, and then the other kinds of fraud. So for blockchain, we're really talking about counterfeit, stopping counterfeits and mislabeling and adulteration. But there is some aspect that could be used to combat investment scam and some of the other more business related type frauds. So what's interesting here is that the things that have been tried over the years, since probably the early 80s, to combat wine fraud mostly have failed commercially. There's a variety of reasons for that. Some of them it has to do with the fact that once you open a bottle of wine, its value goes to zero intrinsically. It has a lot of value from a emotional perspective of the part of the person that's actually drinking the wine, or people, but in terms of monetary value, it's zero at that point. So what you're looking for here are techniques that basically let you not open the bottle and try and make sure that you know what contents are in there at the same time. Is it the real thing? Is it fake? So people have been looking at things like NMR, nuclear magnetic resonance, something called inductively coupled plasma spectrometry. And one of the more humorous ones here actually was an IR sensor. Back in 2006, NEC rolled out something called the WineBot, and you'd put a sample in and it would scan it with the IR spectrometer and tell you if it was legit or not. I don't think it worked very well. So people also have looked at doing things where they put little markers into labels. So Kodak had some very specialized printing technology at one point. People have looked at putting DNA for the grape actually in the label. and then also putting holograms into the label. And those have all either not worked or just been able to be forged. The hologram specifically, very recently, there was a case in Italy, 2020, where the perpetrators did forge the hologram correctly on a high-end wine. So people lately have been actually looking at using AI, more specifically machine learning, coupled with these kinds of techniques. But in general, they do require opening the bottles to get very accurate information. But it does work. So if you don't mind opening the bottle, you can do this. Now, the problem is the only people that can actually open the bottle without losing the value are the people that bottled it at the chateaus and the domains in France, for example, or other kinds of vineyards where they actually do the bottling. So you can look at this in more detail, but it's really, there's a problem here in terms of technology being able to actually accomplish the application needs. So, the void is, how do I tell if the wine is fake? We don't really have good technology yet, except blockchain. So what's interesting here is back around 2015, people started getting very interested in using blockchain to combat wine fraud because they could stick a near-field ID chip or an RFID chip inside the capsule. So the capsule is the part that basically covers the cork or the screw top in metal foil. If there is a capsule, sometimes on the screw tops there isn't. But there's problems with this because it's hard to get RF signals in and out of metal. So this Seal product here, they use like a plastic top with a metal side that gets around the problem. But the advantage here is that you can incorporate any kind of data you want to regarding the product in the blockchain. So it could be the grapes were grown in this particular field on, this is the growing period. This is the weather during the growing period. Here's actually what vats the grapes went into. Here's how this was blended by the vintner and then bottled. Who actually did the blending, who did the bottling. Any information you can think of, you can actually put into the blockchain. And the great thing about blockchain is, as most of you probably know, it's an immutable record, meaning you can't alter the actual data. And in the context of wine, what's even better is once you open the bottle, if you put the chip in the right place, you're probably going to destroy the chip. So therefore, intrinsic value is gone. You don't actually need the chip anymore. But there's a number of companies that you see on the left have kind of been up and running since about 2015. Some of them have gone out of business. So this is, risky. It's emerging technology. But a number of them are still commercially active, and it's worldwide. The list on the left I generated, there's actually a paper by Perry et al. For 2024. They had their own list, and it's pretty consistent in terms of who's doing what with blockchain and wine. So it's mid-life cycle because it hasn't quite hit mainstream adoption, but some of the big wine producers, especially for the high-end wines, are doing this right now. And I have questions in terms of the market here, and this is applicable to defense also. So, given that there's a start on people adopting this in the wine industry, I'd like to know what year a majority of the wine producers will adopt it. So if you go back to that graph I showed on digital effects, when are we going to really sort of start to saturate? On an asymptote on that blue curve I showed you for special effects, when is that going to happen in wine? And maybe not quite saturate, but close. That's important to think about. And there's some other aspects with wine that are a little bit unique. So like a low quality wine, you could probably drink now or within a couple of years of bottling. But a very high end like Bordeaux, you have to let those sit for a while. It could be 10, 15, 20, sometimes even 30 years to let those sit in a vault and before they've matured and they're in their drinking window. So the issue here is you've got certain things coming on the market that, may be drinkable now, but the vintages are basically the same. So like a 2025 vintage is 2025 vintages, but you won't be able to necessarily taste at peak a Margaux, for example, that came out in 2025 until 2035. And there's a discrepancy then, what's going to come on the market first that actually has the blockchain incorporated, if that makes sense. There's also another fine point here. Wine is typically stored if it's high end. So, you'd want to incorporate into the blockchain. Okay, it was stored here. Here's the humidity conditions and so forth in that storage. So there's reasons to have the blockchain there. But in terms of consumer impact, you're not quite sure what's going to hit first on the market. Again, why is this applicable to defense? So I'd argue defense is a little bit less adopted even for blockchain than wine. There's a few pilot programs when I did some research I could find. There's arguably more that I don't know about, but here are some of the major ones. I won't go through them, but at least in the US, it's starting to move in terms of blockchain adoption. There's been some mandates recently where um, it's going to have to be studied in more detail and more pilot projects enacted. But you can see it. This size of this list is probably about the same size as the offerings in the market for wine. So it's a pretty good comparison in that perspective. So in fact, the 2025 National Defense Authorization Act did have verbiage in it indicating the DoD go ahead and investigate blockchain a lot more seriously than they had been in terms of increasing the number of pilot projects and implementation, more specifically for supply chain security and also supply chain transparency. And I won't go into this in detail. You can go ahead and look it up on your own. But the bottom line is, I think blockchain's coming in a big way for defense, and it's really kind of mid-life cycle at this point. And I looked at some estimates on compound annual growth rate just for blockchain and defense. They kind of vary widely. Maybe the truth is somewhere in between, but it's definitely going to increase. So it's probably a good area to look into if you're into this into blockchain and supply chain and logistics management and so forth. But you can see there's still risk because on the wine case, there's a few companies that tried to get into the market and they failed. So I have similar questions regarding the years that in terms of defense introduction of blockchain, when will that really reach saturation? I'd like to know, really when about 50% of products in the defense market will incorporate blockchain. And in defense, it's important because we're all worried about supply chain vulnerabilities, especially with semiconductors and things like that. If you can incorporate blockchain properly, it alleviates some of the pedigree issues that you might have, wondering where the products actually came from, or along its transit, did someone tamper with it, so forth. So this is important, I think, from a defense perspective. All right, let's move into the early life cycle. So this is really thinking about if I'm a change agent and I want to help nurture some emerging technology to do the following. I want to bring manufacturing in the US the capability to reconfigure itself within 24 hours to build almost anything. There's a lot to think about here, and I'm going to just lay down sort of a notional framework to get your, I guess, juices flowing cognitively on this. This is by no means the right solution. It's just the way I would approach the problem. So the first thing you have to do is really think about the void. Well, I described the void to you. It's really needing this capability to manufacture in 24 hours. So you have to be really creative. You've got to think through what are the constraints in this case. These can be things that are real world constraints, like it takes a lot of money to shift over production lines and time, as well as pragmatic. You might have to think about, how do I train workers? There might be things that you just can't overcome. For example, you may not have enough power in a particular region, and that's kind of out of the scope, maybe, for this sort of a thought process. Or someone says, I need it done in 3 months, and you say, well, it's going to take me 3 years. And then likewise, if it costs $1 trillion, probably won't happen. But if it costs, billions, that may be possible. Then you have to think through what technologies actually exist that you can use or adapt. Like I talked about in the beginning, these could be things that were overlooked, that were never used in this context, or you actually just have to create them. And then think about, how do I go about planning that development or shifting of the usage of the existing technologies. And then you have to really actively nurture these things. you're going to face resistance, especially from people that are more reluctant to risk and change. In the computer graphics example, again, there's definitely was resistance in terms of timeline. You saw it take a little while to really take off after probably about 7 years after the first CGI character to the movie that really had all the CGI creatures. And you're going to see things like that here, where you've done some kind of a proof of concept. People sort of see it, but the ones that are very risk adverse just aren't going to get on board. So the best thing you can do is really find the path of least resistance, keep your vision sound, and keep things moving in the background until it's really ready to roll out, show people. And if you look over history, there's a lot of people who have done this with emerging technologies successfully. And if you have questions on examples, find me after. I can give you some in an offline context. And then finally, when the technology is ready, meaning the change agent, you deem it ready for insertion, absolutely go ahead and do it. Don't wait. And what you're looking for is, does it meet your minimum viable requirement for use? So in this case, can I actually build things that are different in 24 hours? Maybe it's not anything in 24 hours, but it could be, things that are significantly different enough in an environment of a factory to showcase, yes, this works. And the stakeholders then really won't have any ammunition to push back. So as I mentioned, factories really are expensive. They're purpose-built. For example, automotive and aircraft production lines, they have highly specialized equipment. There's dedicated process steps. They typically use dedicated feedstock. This equipment is very expensive, especially in automotive. Some of the stampings are very expensive, take a lot of time to produce. You can't just change these things on a dime. There's a reality here, right? So even though my intention is to do so, it's hard to think about it in terms of existing factories. But we can think about using them in different ways, more specifically the equipment in different ways. So we could maybe say, take a welding machine that is in an automotive factory, reprogram it to do a different kind of welding or welding pattern, right? And we can change the head on that machine, maybe do a different kind of actual feedstock that we're welding. We can maybe think about, well, maybe I don't have to weld it, but maybe I want to introduce some arcing current into something. I can't think why you'd want to do that, but you have to think creatively here, right? And so think about how to use the existing equipment differently. But in general, you may not be able to do this. So you have to get even more creative. Well, can I add anything to it? Can I have some adaptations mechanically that are controlled with software and computers to make things do things they're not supposed to do? For example, maybe I want to automate a drill press that was built for a person. Well, I can think of a mechanical contraption that would be controlled by a laptop that could pull the lever and automate that. And I could make some kind of a conveyor belt that would take work in process into the drill press and take it out once it's done. There's things you can do there, right? You can even have something that would change out the head on the tool head on the drill press. Maybe, change the bit or whatever you're trying to do, the tap. So there's things to think about here. Again, it might be a little Rube Goldberg-ish, but if you're really trying to do this in a context where you have to get this done, you have to think about dumbing things down a little bit. You don't need the exquisite solutions, right? You have to think about the lowest hanging fruit, the things that maybe give you 80% of the capability, but get done what you need. So when I gave this some initial thought, I said, okay, factories are hard. Let's maybe go to some sub-tier of a factory. What about machine shops? So every machine shop I've ever visited, they've got a lot of equipment around. Some is very automated, some is very manual, but they have much more flexible processes. And the equipment is very flexible in terms of ease of use if you're trained on it. And there's a lot of machine shops in the US, over 32,000 currently. That you could mobilize as a big capability. The other thing about machine shops is you have to think about how to automate this. Again, a lot of the equipment tends to be manual. So, you're going to have mechanical systems that are basically strapped on to automate things that are computer controlled, like I talked about. And you're going to have to think about, can I build things less exquisitely so that maybe it's okay if they break occasionally, or more. Like for certain kinds of uses, maybe you're trying to build things that are attritable. So you only actually have to build it once and you don't really care. It's breaking through its first use by design, right? So there's things you can think about trading in addition to the production. It actually has to do with the product itself. And you also need to think about using other feedstocks, right? Not just metal. There's plastic, there's metal, there's other things. So let's talk about technologies that exist. So more recently, we have large language models. And as I showed you with the AI video generation, these are very robust. You can do a lot of things with them. I'll get to this in a minute, but we have a prototype on using an LLM to basically generate CAD files very quickly off of a couple pictures and a text description. That's kind of ingenious in this application because you can basically look at what equipment you have in your machine shop and say, okay, here's what I've got. How do I make this? And it takes a little bit of the I guess the impetus off of the person, but more using the tools available to get the job done. You've also got to think about automation software that does exist, but you need people to program it. Again, LLM can help actually update code very quickly. A lot of people are using that now to great effect. You've got to have computers and equipment that are networked, computer controlled equipment. Computer vision's been around a long time, but that's actually very important here. You can feed the digital imagery into LLM so they can control things given your text direction. We've had subtractive manufacturing for a long time. We've had forging and casting and other types of processes for a long time, various kind of molding, for example. We also have additive. Additive's very powerful when used in the right context. It can also be very impractical in certain contexts. Example recently, someone I know could have milled something out of a piece of ABS. They chose to do an additive process. It took them a week when it probably should have taken them about 20 minutes. And they spent $500 when it probably should have spent maybe $10. So additive's great, but be careful when you apply it. And like I said, you could use a whole variety of feedstocks. And in fact, now there's cellulose feedstock available. It's called cellulose composite, and you can make things that are sort of like plastic, where they have very organic shapes or very unique shapes. It's a good combination of capabilities. And the cool thing is you can construct materials and structures out of recycled waste in this case. So just boxes, paper, grass, trees, roots, whatever has cellulose in it, you can actually make things out of. And even the resin systems can be naturally sourced, which is kind of interesting. And then with metal and plastic, you can obviously recycle. You can take metal, break it down to powder, again, use it in additive. You can go ahead and cast it, whatever you need to do. And in fact, there's things that are unique you can think about. There's a company in Chile actually called Rudernack Biotech. They can take bacteria and break down metal parts extremely quickly, I mean, overnight, to output pure metal powders. I've seen pictures of this from the company. They can break down things the size of like a radiator in a car or even a car engine block overnight. You don't have to take any of the gaskets out or anything that are rubber. The bacteria eats around that. It just digests the metal, which is kind of cool if you think about it. So if you're trying to do something quickly and get more feedstock from scavenged material, that kind of approach may make sense from a creative perspective. So again, the LLMs really open up the design space because you can feed in all these things that you have available and let the LLM figure out, okay, how can I vary what I'm making based on changing requirements? Those could be mission requirements, they could be quality requirements that you can dial in, and what feedstocks you have. So I think that's probably the most powerful thing here is we need LLMs that can basically redesign parts, given sketches, pictures, information on what's existing in functionality descriptions. So you can think about using this in the field. And you want people that are not necessarily trained well to be able to use this equipment. So it has to be very user-friendly. And like I said, we have a start on this, and I'll show an example of it coming up. We also need mechanical computer-controlled systems, like I said, that are strap-on to automate things that are only manually operable. Again, if you're in the field and you've got a bunch of privates around, these people are smart, but they're not necessarily trained in this area. So you need to help them as much as possible, and you want to automate as much as possible. So if you take this to the extreme case, you can think about just having humanoid robots effectively, and there's people working on this commercially now, that are running LLMs locally so that they can operate the machines. And the reason you want them to be humanoid or close to humanoid is that these machines that were manual were designed for human use. So you have to at least be compatible on that front. But this sort of sets the lowest common denominator for you can have a whole team of these robots go into any machine shop and start making things. And you can control them at a higher level with your higher level LLM, so to speak, and provide the design that they're trying to actually produce. And then go ahead and incorporate feedstocks of any kind to make this happen. So in that vein, we put together a short movie, again, AI generated, thinking about this problem in very austere environments that are forward deployed. And it's a real world mission set. The context is we want soaring munitions, meaning soaring cellulose composite loitering munitions that can be used from a forward deployed area where people might be logistics constrained. So we can't make these stateside and ship them into theater. We have to build these things in theater with what we have on hand. Now you can stock up some things ahead of time, like the control chips and some other things, but for structure, you actually want to build them in place. So with that, I'm going to show the Last Mile movie.
Damn it, Rodriguez, stop getting in my way. It's already 2 a.m. and we have to finish 100 of these before dawn.
Good thing we only have 19 more to go.
Sorry, Mick. I just... Chen-Hud.
At ease, Colonel Mortensen just informed me that we have a new mission, and as a result, we have to change what we're making. As of right now, we are no longer making missiles. We are switching to soaring cellulose composite loitering munitions that need at least 500 nautical mile range. Sergeant Smith, how long until we can switch over production?
Once I have design parameters. 3 days, sir.
Sir, our missiles just aren't proving effective against those hidden targets. We just can't meet our mission objective. What we need, in my opinion, and fast, are soaring cellulose composite loitering munitions that can fly 500 nautical miles or more and pinpoint targets. Our supply chain is non-existent, so we'd need to make them ourselves.
Major, how long will it take to shift over our on-base production?
Normally about 1 week. But we have this new R&D system from DARPA called AutonoCAD, which may be able to help us do it in a matter of hours.
Okay, John, let's do it. Diaz, tell your team to use AutonoCAD and start making loitering munitions immediately.
Sergeant Smith, how long until we can switch over production?
Once I have design parameters. 5 minutes, sir. Good. Excellent.
Agile manufacturing demands eliminating bottlenecks between requirements, design, and production. Today, we introduce AutonoCAD, an AI pipeline that converts requirements, images, and sketches directly into precision CAD models and manufacturing instructions in under 5 minutes, bypassing low-rate initial production, or LRIP, entirely. Current manufacturing requires months of iterative prototyping and LRIP validation. With AutoNoCAD, we collapse this process by combining breakthroughs in visual language models, spatial reasoning large language models, and real-time manufacturability optimization, which is a novel contribution. This enables direct-to-full-scale production of mission-critical components with guaranteed geometric and available feedstock material and manufacturing equipment compliance. AutoNoCAD is a three-stage process. Stage 1 is semantic parsing, where AutoNoCAD extracts discrete geometric primitives and material constraints from images and sketches, and mission requirements are taken into account. Stage 1 outputs a labeled CAD command structure with semantic annotations. Stage 2 is spatial assembly, where an AutoNoCAD spatial reasoning engine resolves geometry 3D tolerance stackups and computes dynamic load paths. Stage 3 is manufacturing optimization, where a physics-informed neural solver generates toolpaths minimizing subtractive material waste, additive layering strategies preventing warping, and in situ quality control markers for automated inspection.
I hope everyone enjoyed that movie. Again, that was all AI generated as well. The part with AutoNoCAD, though, was a screen capture of us actually outputting CAD specifically for those image sequences you saw there. We went from basically LLM to Rhino script, which is Python based, and then generated from the script the CAD. But it's a very clean process, and that was real time. So it really only took about 2 minutes to do that. And that part came out perfect. That wasn't the most complicated part, but you can see the potential. So moving on to the discussion, becoming an emerging technology change agent is not by any means easy. You have to have a very thick skin. Having done this myself a few times over my career, you got to pick yourself back up when things don't work out the way you expect and just keep going. You have to play the long game and really be committed to the application in the mission space and the technology that you're trying to champion. Your technical, financial, and professional credibility are often always at risk. I wouldn't say under attack, but they're at risk. There's just individuals and parts of systems that are very risk adverse, and they don't like change. That's just always how it has been and how it will be. You just have to figure out how to work through that the best you can and succeed in spite of it. This could be a very long process. As you saw again with CGI, it basically went from 75 to about 93. That's a long time. It's almost 20 years to really start the inflection point on that curve. And for full saturation, it was a good 25 years. So it tends to go a little faster in other industries potentially, but it's a long haul. And stakeholders need to know that up front and agree to it before you really go down certain paths with incubating the technologies. You may get frustrated often, so just be ready to handle that and pick yourself up, like I said, and have some perseverance. If you are successful, it's a huge discriminator for your organization and you personally. Let me make some concluding remarks and then we'll move into questions. So as you saw, it takes very few people to set the course for this kind of a change, a paradigm shift based on emerging technology. In the case of CGI, it was literally 2 people. As I said, it takes a long time for these things to incubate. Just be ready for that length of time. There's always a spark event, I've noticed when looking at things historically. Again, CGI was that film in '93. That was the spark event. And you can always trace it back, whatever you're talking about, to a particular spark event. Adoption is always an exponential curve, and then it asymptotes when market starts to reach saturation. And at that point, the market stagnates, meaning people don't really do anything differently, but they're kind of waiting for the next thing to happen. And at that point, a new change agent, sees a void and discovers and exploits it. And it's not always, but typically the ones that are the ones to do that first and then get to market that are the ones that reap the most benefits. But once the void's discovered and they can exploit it, the cycle renews again. Defense in general does lag commercial industry in emerging technology adoption. We should absolutely look to commercial industry as a model for this. Historically, this was actually not the case. It was the reverse, but sometime in the 90s, it really kind of flip-flopped and defense lagged commercial. I'd argue we have to get back to defense leading commercial on certain application areas. We just don't have I think the bench depth to really lead like we did historically, but in certain places we absolutely do. And I think that should happen. Defense almost always has larger voids because the problems are just so much more complex than commercial industry. But defense, it really is a thing that has a lot of intrinsic momentum and it's high. So we have to have a very strong forcing function to really overcome that and the risk aversion that is in general in defense. Generative AI that we talked about a lot and I used to some effect here is an extremely powerful tool and it applies to many different fields. I happen to make some movies with it, show you how to use it in a context to generate CAD quickly, but it can be applied in many, many different ways. And I conjectured how to use it in the context of rapidly manufacturing products in a machine shop setting. And the products could be really of any variety. I gave you some examples of how we can use generative AI for very significant efficiency and cost savings. In my case, 87% and 99% respectively. And the final thought I want to leave you with is sometimes dumbing a solution down, making it much simpler, less exquisite, still gives you the capabilities you need, but it does so much faster and at much lower cost. So the entry point is just much faster and easier. And this could be done in environments that are in a field, for example, where people that don't have a lot of training can actually pull these things off. And I think that's what we probably want to think about shifting to and getting away from supply chains that are rooted back, stateside when the logistics chain may be cut off. Just quickly, there's some references. If anyone's interested, please feel free to contact me for more information on references or material. And with that, I'm going to stop sharing the screen. You'll still see my video, and we can move into some Q&A. All right, let me look through these really quickly. So there was a question about shouldn't these things be more capable, not less? I'll have to think about that a little bit. It depends what you mean by capable. I think being able to produce things in a austere environment may make them more capable, but I'm thinking more about certain kinds of mission functionality, but it depends what you're trying to do. So like in the case of a cellulose composite soaring loitering munition, it would actually be more capable because the range would be greater than a steel metal structure. And carbon fiber is just difficult to build in theater, especially when you're scavenging material. I hope that answered the question. If not, contact me after. You can actually buy wine now that is tracked with blockchain, but it's typically the higher end vendors. So if you're interested in some specifics, I can talk to Maureen, who's the expert there, Maureen Downey, and get back to you on which ones you can actually buy. There are different vineyards using it. And I did find some in the course of the research, but I don't want to basically cite any specific wineries right now. So again, if you want more detail, let me know offline. Yeah, the heuristics. So someone asked a question about heuristics used by successful change agents who identify paradigm shifting technologies effectively. The answer there is yes, they don't listen to people that are criticizing them. They go their own way. They have conviction internally. They know they're right, and they move ahead. Now that's good and bad. It may mean they're fairly conceited, but it also could mean that they have a superior vision and ability to see far out into the future, in particular application spaces, and just know what is needed. And they stick to their you know their guns there. They actually just don't stop. And that's, I think, the biggest heuristic I can say. Next question. Do you think there are different cultural responses, especially within DoD government community, to disruptive versus paradigm shifting technologies? Does one receive more resistance than the other? Are there best practices for overcoming those cultural barriers? Let me start with the last part first. So from my experience, you really need to socialize your ideas with stakeholders. You need to do that very clearly and early to make sure they understand, A, what the void is, B, what the emerging technologies are you're thinking about to fill the void, and why they may be superior to existing technologies, either in terms of capability, cost, or both. And that sort of gets back to the first question about more capable versus less capable. But there really isn't, in my experience, a huge difference between disruptive versus paradigm, because people misinterpret paradigm shifting. They tend to lump everything into with disruptive. So I think, just be cognizant of, while customers may not understand and appreciate that difference, just make sure you're talking apples to apples. Are they interested in something that's low cost and less capable, or are they interested in something that could be much more capable, but not necessarily less cost? What is their entry criteria? Because it will vary customer to customer. Another question, part of the challenge is educating policymakers that may not have technical backgrounds. And yeah, again, I think it's, in my experience, just being very open and transparent with all parties in the discussion. Thinking back when I'm at certain customer sets, there's people that are technical, there's people from finance, people from other parts of the organization. They all have an input, and you just want to make it very clear as to, here's the technology I'm thinking about. This is why I want to introduce it to solve this particular application problem. And that will help them get up to speed. And use analogies as much as possible. Oftentimes, as engineers and scientists, we might speak too high over people's heads. And the more you can make that accessible to people, again, not that they're not smart, they're just smart in different areas than you are. That is an advantage. And that's the way I'd recommend doing that. When do I think it'll be commonplace for the military to use humanoid robots? Interesting question. I don't want to necessarily speculate on that. I will say this: the hardware is ready. As you guys probably all have seen different news sources and so forth, there's a number of companies making a variety of humanoid type robots. The challenge is twofold. Letting the LLMs run locally on those robots, and there's some people starting to do that now. And then there's also a ethics and safety angle. So is it ethical to do that? I'd argue in the context of manufacturing, absolutely. In support for staff in theater, absolutely. If you're talking about actual operations where those humanoid robots could potentially cause casualties, that's an ethical question. I think that's going to take a lot longer than using them in terms of support roles. And I'm not going to answer whether it's ethical to do so or not in a combat situation where they could cause casualties. I think it's something that the governments around the world are going to have to think through very carefully in the future. Oh, good. We got a ton of questions here. Excellent. Do I try to involve people that take the most time, that are most adverse? Do I avoid them or work around them? I actually don't avoid them. I try and get to them right up front, and really push on, well, why are you so opposed to this? And really work through it and have a conversation. It's better to do that, I found, in practice than avoiding people. Now, strategically, there may be some other reasons why in certain contexts it makes sense to try and I'll say work around. Avoid's probably the wrong word. There's different reporting chains in different organizations, and it may be advantageous to use some versus others. But I have seen in the end, those people are still stakeholders. They will have their say. So it's best to handle that up front. What is one thing I'd have DoD do to promote disruptive innovation? That is a hard question. I think in general, when it comes to disruptive and paradigm shifting innovation, it's really, this doesn't just go for DoD, this goes for commercial markets as well. Just be open to discussing the possibilities. I often have people push back on ideas that, half the physicists say would work, the other half the physicists say it won't work. Well, that's a good enough chance for me to actually try and go get some money to see if it's valid or not with a simple test. And the fact that people are unwilling to fund very simple things to prove or disprove potentially radically altering technologies is a problem. And especially if there's a great void for an application space. So I think it's just be more open to embracing some impossibilities potentially and look for simple ways to prove or disprove them. That's probably the biggest thing I would do there. Can I provide some operational environments where a simpler solution is more beneficial than exquisite? Yes. So in fact, it's the example from the video, the last video. Think about it this way. And I'll put it into an analogy context. Let's say I'm having a bottle rocket fight with my neighbor. We each have some really big bottle rockets, but but I want to actually overwhelm my neighbor with more things. I'm going to find the simplest stuff that's the lowest cost that still might have an effect in my garage to put together as a cheapo bottle rocket to go and bombard my neighbor with before I start launching my exquisite bottle rockets at them. And they're going to probably launch off their exquisites and completely expend their arsenal before I've even gotten to my exquisites. That's probably a pretty good game plan right there to win that bottle rocket fight with my neighbor. So when I think about dumbing down, it's, can I accomplish something in sheer volume versus small numbers? But I can make the sheer volume extremely fast and at very low cost with things that I have on hand. Dumbing down could also mean, if I have an optical system on a spacecraft, let's say, do I really need to have it, look at bunny rabbits from, geosynchronous orbit? I'm just making something up, obviously. Or can I get by with, I just need to see the whole forest. I don't care about the individual bunny rabbits. That's obviously a huge difference. And when you're talking about 80% versus 100% exquisite solution, that's where most of your cost typically lies. So it's a good thing to think through. Like, do you really need that capability? Is that requirement really necessary? Let's see. Will the slides materials be available after this event? I will work with my my team at Parallax. From my perspective, yes. There's nothing proprietary in here as this is recorded. That being said, we may have to mark it a certain way, or we'll talk amongst ourselves and get back to you on that. But I am happy to provide if we can do so. Also with the videos. What is the most promising biotechnology innovation? Oh, that's a good question. Let me think about that. Let me skip that for a second. I talked about lags in defense. This person would contend they're worse than most. The gap between the state of practice and state of the art is growing wider. And then art of possible discussions can be rare. Can I speak to this in terms of paradigm shifting? The best I can do is say again, talk to the stakeholders, talk to the change agents within the government. They do exist. I know of some. Um, they're the people that are actually trying to inject emerging technology, whether it be disruptive, paradigm shifting, or both, into DoD systems. They typically have very high level sponsors, and they have a lot of influence. So if you can find those people, you can start to close that gap a bit. Now, I know the DoD actually is starting to bring on some of the CEOs of some very large companies as I don't know if it's commissioned, but there's some kind of a military uh, officer role they've set up for them to, I think, try and inject some of that technology and close that gap. So I think that the government's handling it in a couple different ways. But if you're trying to actually influence that yourself, go find those change agents. And it sometimes they're hard to find, and it depends on the customer set. Do I think the U.S. will remain a leader in this area? How do we lean on coalition partners? So let me be fairly clear. The number of publications having to do with technology, especially emerging technology, coming out of some of foreign countries relative to the U.S. is greatly expanded relative to U.S. publications. If you look at the military applications for those, they are ripe for military application. I think the U.S. has to up its game. Personally, I do think it has to do with risk aversion and not being so risk averse and not embracing testing out certain theories that are simple to test to see if there's an advantage when there's a potentially large advantage. Some of the foreign countries are much more amenable to doing so, and I think we have to shift that. Over time, if the trend continues, you will see a shift away from U.S. potentially. Although I'm not talking about things that are necessarily classified. These are open things. On the classified side, there very well could be a lot of things going on that I'm unaware of, and that could make that gap either non-existent or shrink very rapidly. But I think the U.S. just definitely has to up its game and be more like they used to be in the past. I mean, if you think about like the Manhattan Project, I mean, that was a crazy idea. And it took a few stakeholders to basically say, yeah, that's a good idea. Let's go do it. And I don't know if that would happen today, personally. I think the environment's different. We want people to think about things more in terms of the what if, what's possible. How do you get in touch with me? I believe NDIA is going to send out my contact info through Parallax afterwards. So look for that. Someone asked what the most promising social science innovation I've seen is. I'll have to think about that also. Okay, someone said they're all 4 commissioned officers. Thank you. That was the commercial CEOs at some of the larger tech companies in the US. Can I apply my thoughts to the semiconductor industry? Yes. Maybe we can talk about that offline if there's specific interest. I do have ideas on how to do that for large language models, specifically, and other AI capabilities to do so. Oh, okay. My contact info is on the lower left-hand side of my video display. Perfect. All right, let me go back to the biology question real quick since we have a couple minutes. I'll have to see if I can find it. So I think in biology, it might be perhaps using some of the AI techniques like people were using for protein folding solutions to certain problem sets. It could be like in the context of chemical weapon defense, trying to find molecules that bind more heavily to certain kinds of chemicals and agents than others that we have readily off the shelf to make them more sensitive to protect our troops better. That could be interesting. Other areas could have to do with enhancing human capabilities, and I don't mean like in the sense of creating a super soldier. What I mean is, let's take the case of a UAV operator. Parallax makes a system called Vigilant Spirit where one operator can operate like 10 UAVs or more at a time. The problem is with the cognitive load, a person can only handle so many. And I think it is 10 at a time. But the system's capable of doing, hundreds potentially. Other UAV control systems have similar issues. What if we could figure out a way biologically, whether, it could be nerve stimulation, it could be neural interface with some kind of offload for cognitive things. It could be just a way to increase, brain's processing speed, to enable someone to actually cognizantly operate 100 UAVs at once. What does that mean, right, in terms of capability? So I think those are the kinds of things to start thinking about. And again, it's far out there, but it's not that far out there. There's people that are already developing technology for neural interfaces that work pretty well in the lab. I'd argue you could probably start to think about how to transition that a little bit. Those are some examples there. Social science is a little harder in that I think social science is a broader context. I'm thinking maybe more in terms of economics, which is a social science. Maybe thinking about how to model certain economic effects or potentially create certain economic environments. That could be very interesting from a social science perspective. Okay, 2 more questions just came in, so we have a couple more minutes. How can scientists get more involved in discussion about AI regulations? That's an area I'm not very well versed in. I think regulations are kind of in flux and in the process of being developed. I would look for the regulatory bodies that are potentially being formed, the people discussing it. On the defense side, maybe go talk to your local senators, Congress people, who may be engaged in those kind of discussions. There's definitely some sort of steering committee somewhere doing this. I'm not as deep into it to be in the point of working on regulations. Let's put it that way. I'm dangerous, but I'm not an AI scientist. Do I believe AI is making people less creative? The answer is no. The reason is you have to still decide what goes into the final product. Every time I make a video or do a prompt with an LLM, what I get back, I scrutinize to make sure it's correct. I check all the references, make sure there aren't any bogus references. That actually happens quite often with some of the models. Depending on when you run your prompts, it may change hour to hour, day to day, because everything's randomized. But I can tell you with those videos being all AI generated, the person is very much in the loop. The person's not going away. What the person does may change in the concept of like digital effects. They're not going to do the effects, but they're most definitely going to be writing the prompts and engineering the prompts to get the actual effect out or the shot out they want. And they're going to be doing the editing to make sure the story is told correctly. So by no means are people going away from creativity.
Awesome. So we're 2 minutes to the end of the call. So Mike, I want to thank you for your time. That was a great discussion, and I also want to thank our audience for your attendance and great questions. So we're going to post the recording online as soon as possible. If you have any feedback about this event, or if you really want to see us cover any other topics in the future, please email us at eti@nbia.org. I also want to take this opportunity to highlight a few of ETI's upcoming events. So, waiting for the slides. So the first one is we have our next Tech 101 webinar. That's going to be on wearable technologies on July 23rd. Our next event is going to be ETI is hosting an in-person short course on private capital. That'll be on the 22nd, and this event focuses on how investors think and how DoD can more effectively partner with private capital to build a more resilient industrial base. We just locked in Jason Rathje. He's the former director of the Office of Strategic Capital. Next. I also want to put on everyone's radar that the annual NDIA Emerging Technologies Conference is coming up. It's set for August 27th to the 29th at the Washington, D.C. Convention Center. We have confirmed speakers such as the Undersecretary of Defense for Research Engineering, Emil, Undersecretary of Defense for Acquisition and Sustainment, Michael Duffey. We also have the Vice Chairman of the Joint Chiefs of Staff, Admiral Christopher Grady. If you want to learn more, please go to ndiatechexpo.org, or you can scan the QR code on the screen for more information, and then you can register there. Next slide. So we also have a classified reading room. The deadline to register for access to this reading room, where personnel can review some of the COCOM's integrated priority lists, the deadline is today. The conference is also going to include classified sessions with speakers representing the COCOM's OSD, other services and defense agencies. And so registration for these sessions is also on the conference website. It'll also feature a one-on-one speed dating sessions with participating government and private organizations. There's more details to come on that. And then the last thing that I want to highlight is that we have a hackathon. Registration can be found at ndiatechexpo.org/hackathon. So with that, I want to thank everybody for joining us, and hope you have a great rest of your day. Thank you.